Hello, Math 263 students. In this video, we're going to take a look at how to use Desmos to check our implicit differentiation problems. Now, hopefully before you're watching this video, you have watched this section lecture from the textbook or through my math lab. So I'm going to go ahead and jump into a specific example, and we're going to look at a familiar equation. So let's take a look at x squared plus y squared equals 16. So we may recognize this equation as a circle. And in this case, we've got a circle with radius 4 centered at the origin. If we want to find the derivative, they're going to say something like find dy dx. And in other situations where we don't have the equation solved for y, maybe we would want to try that first. That would turn this into an explicit equation. But in this case, we don't want to do that. We don't want to solve for y equals. What we want to do is use implicit differentiation to find our dy dx. So let's go through and take a look at our steps for that. So if we differentiate the right side and the left side, both with respect to x, a lot of times I'll notate it like this. The derivative of 16 with respect to x gives me 0. Then on the other side, split your two pieces up. We've got the derivative of x squared with respect to x plus the derivative of y squared with respect to x. So don't lose your equal 0, but start with your easy pieces. The derivative of x squared with respect to x is going to be just 2x. Then when we look at the derivative of y squared with respect to x, if we were doing the derivative of y squared with respect to y, we would have 2y. But since it's not just with respect to y, we need to follow by our dy dx, since we are differentiating with our respect to x. Sorry guys, my calibration is not the greatest on this. And then once we have our dy dx, what we want to do is go ahead and solve for it. So I'm going to go ahead and subtract my 2x over. So I have 2y times dy dx gives me 2x. Then my final step is going to be to go ahead and divide through by 2y. I'm actually going to go to my next page here, just so I've got a little bit of room. So if I look back, I've got negative 2x divided by 2y. So go ahead and cancel those 2's, and this tells me my derivative is negative x over y. Now, in this particular case, we could go ahead and simplify our expression a little bit. Most of the time when you get to the division part, there's not necessarily a lot of simplification we're going to be able to do. So the bigger question that I want to show you guys is how to check these in Desmos when we're not actually finding the equation of a tangent line. If we're finding the equation of a tangent line in Desmos, you could graph your implicit function and graph the tangent line and see if it checks. But when you're just finding dy dx, you have to do a little bit of clever coding to get Desmos to do what it is you want it to do. So I'm going to go ahead and share my screen. Hopefully this will look good in the recording here. And what we're going to do is go over to the implicit differentiation Desmos activity that you guys are going to be working on in this section. So it starts off with a couple of slides just as an introduction, but then slide number 4 is going to be the circle. So what we are doing here is, first of all, plotting our function at the top. Okay, so you're going to see some other functions. Let me just kind of shift over a little bit. You're going to see some ones that have higher powers. You're going to see some products that are going to be interesting. Some ones that we don't have products but have really interesting graphs. So let's go ahead and take a look at this guy again. What this formula allows you to do in Desmos, or what this coding allows you to do, is enter the derivative formula that you found. So notice your dy dx is a function. It involves x and y. So in this case, if I type my function in, m of xy represents that slope in terms of x and y. Now the problem is we can't just type f prime like we did when we have an f of x to check our derivative. So this is our workaround. So what this does is allows us to, on this line right here, allows us to pull the slope m of ab at any point using this function we just defined and write the equation of a tangent line. Now, it's actually utilizing the red point that we see out here. So notice right now, when my red point is not on the circle, this is fairly meaningless. What we want to look at is what happens and if it looks right when we are checking our points on the circle. So, for example, as I slide my red dot around, notice the equation of the tangent line. It doesn't tell me what that equation is. It's just represented symbolically over here. But the tangent line changes as I slide around my circle, which makes sense. I've got a positive slope in quadrant 4. I've got a negative slope in quadrant 1. That's going to change as I go around. So what this program allows you to do, or what this coding allows you to do, is calculate the derivatives. For example, in this case, you will fill in your slope and your equation of the tangent line. Actually, I've already done that equation of the tangent line. So you'll just need to fill in your slope. And then if you drag your point around, notice there's nothing right now, there's no tangent line. But once you put that formula in, it'll create that tangent line. And if you drag it around and it looks like a tangent line, you found the correct slope formula. If it doesn't, then you don't have a check. Let me illustrate what that looks like. For example, what if I just did negative x and I didn't divide by the y? Then notice, sorry guys, as I pull my red dot along my circle, this does not look like an equation or does not look like a tangent line. Okay, maybe it does at like one specific point, but it doesn't continue to look like a tangent line as I go around my circle. So this is the case of something that doesn't check, whereas if I have that divided by y, it does. So use this to help you. Once you've done a couple implicit differentiations, following along with a lecture video, hopefully you've already done that, try your slide 4, try your slide 5. You're going to get into, I mentioned, a product in slide 8, and then also another product with this xy squared in slide 9. So hopefully this helps being able to check. Let me know what questions you have. Thanks, guys.